Hello, everyone. You're used to seeing zetamath here on the channel. I am zetamath's husband, Tristan. We're going to try and do some recordings together. We'll see how this goes. This is our very first attempt at this, but we're going to see about solving a puzzle together. So, the puzzle we're going to try to solve is called The Final Shot, Four Corners 4 by Tallcat. In this puzzle, we have normal Sudoku rules apply. Digits on an arrow must sum to the digit in the circle. So these could be 1, 2, and 3, and that could be 6. So the purple lines are Renban lines. On a Renban, the digits must be consecutive. So, like, these could be 5, 6, 7, 8. But they could go in any order. And this is a valid Renban line. And finally, digits on each of these main diagonals can't repeat, which means these diagonals each form an extra region of the puzzle. Now, by convention, the one I have highlighted here is called the negative diagonal, and this one is called the positive diagonal, and we'll try to stick to that even though there are valid arguments that it should be the other way. But we'll say this one here is the positive diagonal, and this one is the negative diagonal. And those are the rules of the puzzle. So let us get started. So a classic thing with diagonal puzzles with arrows with things in the corners is that because this arrow has 3 cells in the same box, it has to be at least 1, 2, and 3, which is 6. So this has to be at least 6, so it's 6, 7, 8, or 9. That applies to all of these, since these all have 3 cells in their arrow. But because of the diagonals, it's going to turn out that these are actually 6, 7, 8, and 9. This is a set of the digits 6, 7, 8, and 9. Because if this is a 6, well, these can't be 6 by Sudoku, but this one can't be 6 because of the diagonal rule. So any digit we put in one of these corners can't repeat in the other corners. So these are a set of the digits 6, 7, 8, and 9. Now I wonder if we're supposed to look at these
They sure look suspicious.
longer Renbans, especially that they're kind of pointing into this box, although this one sticks into it.
Normally, you don't know anything about a length 4 Renbon, but these we actually know are length 4 Renbons that can't have 8 or 9 on them.
Right.
Uh, and so, if you can't have 8 or 9 on you and you're length 4, that means these both definitely have a 4, right? 4 is the middle of 1 through 7.
I think so, yeah.
There's a
So
4 on
one,
that
two,
one.
three, 4, 7, 6, 5, 4. So they definitely have a 4 on them.
And I know you don't like pencil marking across boxes, even though I'm an anarchist who just does it willy-nilly, but you can shade those if it will make you happy to just to emphasize where the 4 is actually going.
Sure.
Uh, I thought that was going to tell us that that one wasn't 7,
Oops.
but it doesn't at all tell us that for about 16 reasons.
Yeah.
So I think the next thing to think about is, okay, we know those have a 4 on them. And we know one of those actually looks at a 7. And so the one that looks at a 7 also has to have a 3 on it.
Um, why do we know one of these looks at a 7? Why couldn't this one down here be 7?
Oh, well, in that case, one of them looks at a 6, which is even better.
Well, that's
Because
true.
if one of them is looking at a 6, then in fact, is that possible? Is it possible that row 1, column 9 is a 6? That might be too many digits.
So if this
Because
is a
now
6,
these Renbon have to contain 2, 3, 4. Yeah, that's not possible because look at the Renbon at the top. If that contains 2 and 3, then the 6 arrow breaks immediately.
right.
Because now, if I want to make a 6, just to explain that, if I want to make a 6 arrow, I need it to be 1, 2, and 3, but I now have to put both 2 and 3 in row 2, column 7.
So now we have,
And in this puzzle, we cannot do that.
well, now we have, this could be 2, 3, 4, and something. It doesn't matter what else. Let's say 5, and now we have these 6 digits coming from 5 different numbers, is one way to look at that.
Mhm.
So, okay, so this is definitely not a 6. We have our
Ah,
first elimination of the of the
the
puzzle.
puzzle. So I think the question to ask is where are 7, 8, and 9 in row 1 and in, sorry, yeah, in row 1 and in column 9?
Okay. 7, 8, and 9 are not here. 7 could theoretically be on this line.
Right?
So
But
we
7
could, so
can't,
we have one of 7, 8, 9 here, at most one of 7, 8, 9 in these. No 7, 8, 9 in these. So there's definitely a 7, 8, 9 over here, and possibly both of these if this one doesn't have a 7 on it.
and it's not possible that both yellow Renbon have a 7 on them. Because if both yellow Renbon have a 7 on them, then we've now made 3 of these circles only able to be 8 and 9.
Yes.
So one of these Renbon, I don't know which one, but one of them uh wait, sorry. I don't think we know one of them has to have a 7. We know they don't both have a 7.
I don't know that well, wait. I think the answer is no, we don't.
Okay, so let's assume for a second that neither of them has a 7
Okay.
and highlight that have to be 7, 8, 9 if neither of them has a 7.
Neither of them has a 7. This is 7, 8, 9. These two are 7, 8, 9.
Mm-hmm.
This is 7, 8, 9, and this is 7, 8, 9.
Yep, all of those have to be
All of
7,
these
8,
are
9.
from 7, 8, 9.
Uh, which is a problem because why? I mean, it definitely means that that one down there is a 6, for
So,
whatever that's worth. The one in row 1, column 9 has to be a 6 because we've
so
said all of those are 7, 8, 9.
this digit in row 1 would have to go exactly here
Yep.
because it sees the other two.
Mm-hmm.
And this digit in row 1 would be
Would have to be that
here.
one. Yep.
I do not feel able to articulate why this is broken.
Okay. So here's a different question. Can we put 1 on the yellow Renbon? And I think the answer is almost certainly no.
That, yeah.
Yes. In fact, the answer is very definitely no.
So this is 1, 2, 3, or 4. These are at least 5 and 6. And that's just broken.
Yes.
So we
So
definitely
1, yeah.
So if we can't put a 1, then there's certainly a 5 on it.
Yep. Yep. Because now we're coming from 2, 3, 4, 5, 6, 7. Yeah, and so now we need to have 4 and 5 to join our friends. And the one that doesn't have a 7, and keep in mind they both could not have a 7, but the one that doesn't have a 7, it's actually only coming from 2, 3, 4, 5, 6. And so it has to have 3, 4, and 5 on it.
So this one also has 5 on it,
Mm-hmm.
because the same logic is going to apply.
So the one in the row and the one in the column has to go. Uh,
It's probably going to have to go on the arrow.
at most, one of them's not on the arrow. So to make the world's tiniest deduction, we know that one of. Uh, sorry. Yeah, we know at least one of these has a 1 on it. Sorry, I was going to say something dumb. Uh,
I mean, what if we had 1s in these
well, it
places?
can't do that because as soon as there's a 1 off of the arrow, it makes it a 9, and we only get 1 9.
Yeah.
The goal of almost all of these puzzles is to prove that the 9 has to be a 2, 3, 4.
Well, there still
Just
could
be,
be a 1 here. Oh, but
but
these
you
would
just put a
both be
1 in the
9.
box. Sorry, I'm pointing as though that helps.
Yeah, I
Yeah,
can't see
those would
you.
both be 9. Okay, so what about a 2? Can we put a 2 on the arrow? And I think the answer is that that's insanely restricted. Not on the arrow, on the Renbon.
Oh, on the Renbon.
I think we can only put 1, 2, possibly. Because if there's a 2 on the Renbon, we now can't use 2, 3, 4, or 5.
So this would be 1 and 6 at the
That would have to
least.
be exactly 1 and 6, and that would be a 2 there on the tip of the arrow.
So we can only put 2 on at most one of these.
Yep. So at most one has a 2, and at most one has a 7. Have we narrowed it down now? Sorry, is that does that say one of them has to have a 2 and one of them has to have a 7? Let's see. What is the range? We know it goes from 2, 3, 4, 5, 6, 7. No, that's too many.
Because there's 3, 4, 5, 6 in the middle.
People are going to love me counting on my fingers.
Which has neither a 2 nor a 7. Now, if this is 3, 4, 5, 6, then these would have to be 1 and 2. But this could be just about anything.
I really wish that Renbon didn't dip into box 3 like that, because I want to think about what digits these Renbon are allowed to have in common and where the digits that they have in common have to go in box 3. But it's real annoying that
Yeah,
the one that has in common
it's more like
is
a
there.
rotational thing where this is pointing into box 3 and this is pointing into box 9. I just gestured
Okay,
at the
I,
camera as
I
though you can see me.
I have another observation. The length 3 Renbon can't have 1 on them either, which is going to finally give us a digit that has to be on them.
Okay, these can't have 1.
Because if they did, they'd be 1, 2, 3, and then the 2 arrow cells that they saw would be at least 4, 5, which is broken. Because that would make the arrow at least 10.
Yes. So neither of these can have a 1.
Yep.
And
So
that does what?
they can't have 1, 8, or 9. Or are we not quite there yet? Let's see. Sorry, let's do that again. Okay, so if they can't have 1, 8, or 9, then they come from 2, 3, 4, 5, 6, 7. Oh darn. So yeah, so it's possible
Yep,
that they don't have any digits
yep.
in common. Although again, I think across the entire grid, we can only put a 2 on one of these Renbon. because if we put a 2 on a Renbon, it immediately makes the Renbon it looks at. Oh no, sorry, that's not true. This one, if one of these length 3 ones has a 2 on it, it makes the Renbon either 126 or 125.
By the way, I just want to make a quick observation that these are a 6, 7, 8, 9 because we can't put 6, 7, 8, 9 anywhere else in the center box.
That is an excellent observation. And we can't have 6, 7, 8, 9 anywhere else in the box because everywhere else on the. Wait, is that true?
Everywhere else on the box is on a. Oh, wait. Hang on.
I
I
I
no
no
longer
longer believe
believe
you.
myself.
I believe that row 5, column 5 is from 5, 6, 7, 8. Sorry, is from 1, 2, 3, 4, 5.
Yeah, this one certainly can't be 6, 7, 8, or 9. But these two don't see each other. So I was wrong about that.
So here's a question. These two Renbon both have 4 and 5 on them. Is this going to let us do Sudoku on any 4s and 5s? Because we know, for example, that 4 and 5 in row 1 is of course quite restricted. It has to be in one of those. They each have to be in one of those places. In box 3, one of them could go in yellow, but the other one has to go in one of those few cells.
So yeah, the other one goes in this 2x2.
I'd really love to be able to prove you can't put 7 on more of these. We've said you can put 7 on exactly one of the Renbon along the border. You can put 7 on one of the length 4 ones, or on one of the length 3 ones, or on none of those. But as soon as you put a 7 on one of the Renbon, you force the two circles it looks at to be 8, 9.
And we couldn't, for instance, have a 7 on both of these and a 7 up here.
It's because it also forces the 6. The 6 would also have to be up there, because the 7 goes on the Renbon with a 6.
Schrodinger's hell.
Yes. So, we'll do those puzzles tomorrow, probably, or maybe we won't get to them if there's too many birthday puzzles, but the Schrodinger cell puzzles are coming. So did we say we can't put 2 on both yellow Renbons as well?
Yes, because
Yeah, because
2
it
forces 1
forces it
and
to be a
6.
9. Yep.
So 2 forces the thing it looks at to be 9. They think the same is not true of this. If you have a 2 here,
Yeah, it could be a 2. Sorry, if you have a 2 there, it
you'd
could
have 1,
be
5, and
2. Yeah, you could make a 1, 2, 5, 8 arrow.
you know.
So if 1 is on all of the arrows, then 1 is ruled off of the entire X, and so 1 in the central box would go in the plus. I'm again sort of like trying to fantasize about how it is we're going to prove that the 9 arrow has to be a 2, 3, 4 arrow, because I assume that's what we're trying to prove in our lives. Uh,
So if it is a 2, 3, 4 arrow, then you need exactly 2 and 3 here with a 4, 5, 6, 7 Renbon. Though if
unless
it's,
it's a 2, 3, 4 over down there.
yeah, is it possible this puzzle is smarter than we are?
one never knows. I mean, it's always a realistic possibility. Uh,
So we know one of these is 1, 2, 3, and we know one of them is 1, 2, 4.
and we probably should record. We know these are definitely from 1, 2, 3, 4, 5, 6. They're not from 7,
Sure.
8, 9. But I mean, we were earlier noting about how restrained where 7, 8, and 9 are in these rows and columns, which is why I now maybe also think we should think about where 7, 8, and 9 can go in these boxes. Let's think about the box where the arrow has a 6 on it. Uh, in that box,
Although there isn't necessarily such a box.
there is, because it's a 6, 7, 8, 9 quadruple.
Oh, sorry, you mean in the circle.
Yes.
I
Uh,
thought you meant in an arrow
sorry,
still.
I could have been more clear. Uh, but in
Okay,
such a box, we still have to put a 7, 8, 9 somewhere in the box. It's not going to go on the arrow, and so we have to put 3 7, 8, 9s in the box. Uh, maybe you're so it's not quite enough to force that one of them has to go on the diagonal, unfortunately. Have like an 8 9 pair exactly there on the off diagonal cells, and a 7 on the Renbon if it were there.
and then these would be 4 and 5.
Yes. So yeah, maybe we should think about the Renbon that gets looked at by the 6. The Renbon that gets looked at by the 6 can't have. I guess it just can't have a 1 or a 2 on it, which we've said is true of. I guess it's not true of all of them. The one that's looked at by a 6 definitely doesn't have a 2 on it.
So if this is a 6, is this necessarily
Oh,
going to have to be 2, 3, 4, 5?
that's a good question. Because it can't have a 1 on it. Yeah, that's actually a very good question. Uh,
So what does that mean? So if this is 2, 3, 4, 5,
that
what
doesn't
does...
work. That breaks. That's beautiful.
That's
Okay,
it.
good
That's
job.
it. You
Yep.
can't put a 6 here or here or here
Yes,
because the
yes. Well
logic is
spotted.
symmetrical.
Yes. Do you want to explain clearly for the camera why that can't be a 6?
Okay, so if we have a 6 here, now this can't go as high as 6, but it still can't have a 1 on it, so it is 2, 3, 4, 5.
Now the minimum cells the arrow can have on it are 1 and 7.
Right, which we've said we can't even put a 7 on here. Or
Yep.
we could say we have 7 cells that are coming from 1, 2, 3, 4, 5, 6. That's another way.
That is another way to say it. Yep. So, okay. So we've placed the 6.
Yes, we get to... What did I just do?
I
Redo.
have no idea. Oh, yeah.
Yep.
Uh,
So this is not a 6. This is not a 6. This is a 6, and we do a digit dance. Digit dance. Digit
woohoo!
dance.
So now that arrow has to have 1, 2, and 3 on it.
Yep.
Okay. And so now that Renbon now definitely can't have a 2 on it.
Right.
And so this arrow now comes from. Oh, it is 3, 4, 5. It can only be 3, 4, 5 because it's looking at a 6.
Right. So this is 3, 4, 5.
And we get another
So
digit.
we get a 3 up here.
Hmm.
1,
And
2,
so
3,
that
4, 5.
digit is a pair of.
So these are all 7, 8, 9.
Yep. Yep. Beautiful. Okay, so what about the Renbon that goes vertically?
This
So
one.
it still can't have a 6 on it. Yep. So it comes from
And this one
2,
can't
3,
be 1,
4,
2, or
5. Yep. So it comes from 2, 3, 4, 5. which means it definitely has a 3 and a 4 on it,
Yes.
which means those cells up there definitely aren't 3 and 4. And they're not 6 either.
Yep. So let's see. This could still be a 1-2 pair, which is the only way this is 7. And if this is a 1-5 pair, this has to be 2.
Mm-hmm.
So this one is only 2 or 4, I think. No, 2, 4, or 5? Oh, I'm
Why can't
confused
it be
now.
6?
It could be 6.
I think there's lots of possibilities. You can say that row 7, column 1 can't be 2 or 3. You actually said that out loud. You just didn't pencil mark it.
I keep hitting the wrong buttons. Can't be 2 or 3. Not a 3. So 3 in this box now is definitely here, which is something.
It is something. And so 3 is also restricted to 3 cells, both in box 1 and in box 9.
Now, could this really be a 3? 3, 1, 5 does
Oh,
work.
that's an interesting question. Yep, 1, 3, 5 is the only way that could be a 3.
Okay. And I guess this doesn't even technically have to have a 1 on it.
It does. That's I would my brain was just there. Because if it's a 2-5, it breaks the Renbon.
It's a 2, 5. Oh! Okay. Right. Then all 3 of these come from 3 and 4.
Mhm.
So there is a 1 here.
Which means there's also a 1 on the arrow in row 1.
Right. Where does 1 go in row 1? Definitely here.
You can note those aren't 4 and 5 on the
Oh, right.
candidates there.
Because there's.
We know there's a 4 and a 5 in the Renbon.
Yep. Same is true down here.
Mm-hmm. So there's suddenly so many different things going on that. In fact, actually, what we have is we have a 1, 2, 3, 4, 5 quintuple in column 1. So those 2 remaining cells are 7, 8, 9.
1, 2, 3, 4, 5, 6. So these are 7, 8, 9, is what we're saying?
Yes. The annoying thing is I don't know if that 7, 8, 9 is the same as the 7, 8, 9 that's in the opposite corner. Because that could sneak off into
This
this
one, you
other
mean?
cell. Yeah. Because there's one more place that could go in box 7.
Oh, this digit could go
Yes.
here,
Mm-hmm.
I suppose.
Okay, but now. Oh, I think I was about to say something that was wrong. So let's actually write out the candidates for row 3, column 2, as you were doing before, now that we know that that arrow has to have a 1 on it. So
Okay,
if it's a 1 and a 2,
then
it could
this
go
is
with a
4, 5, or
4.
6.
Yep.
If it's a
If
1
it's
and
a
a
1 and a
5,
it's 2 or 3.
it's 2 or 3. Well,
Damn it, tallcat, damn it.
that didn't
Uh,
go well.
it did not go well. I will totally admit that. Okay. So where is 1 on the positive diagonal?
Okay, well, it's not here, and it's not here, so it is in this box.
Mm-hmm.
Now, if we could prove there was a 1 on this arrow, that would place the 1.
Where is or what's on the Renbon in column 3? Is that restricted at all?
This?
It can't be 1, 2, or 3. It can't have a 4 on it, can it? Well, maybe it just can? If it's 4, 5, does that break Renbon?
It's 4 or 5. These will have to be 2 and 3 with the 4.
Which seems okay. So maybe that's not quite restricted enough yet for us. So in row 8, there's a 3 already. So that cell is not a 3. And the 3 in this box is definitely in the top row.
Yes. Now, if there's a 3 here, that definitely means this is 4, 5, 6, 7.
Okay, so let's think about that. So that would make this the arrows an 8, 9 pair.
7 would be over here. You'd have 3s looking into this box, since this would have to have a 3 on it in that case, since it's got a 7 over here. You'd have 3s looking into this box from these directions, so you'd have a 3 in here. I don't know, it would do a lot of stuff, but I don't know that we can say it doesn't do that.
Trying to think about where 6 is in row 1 and if it's restricted at all, if it tells us anything.
So if
6 is
it's
on.
So if 6 is here, we definitely have a 2, 3, 4, 5 Renbon.
Mhm.
6, 9, and then these would have to be 7 and 8.
Yeah, I don't think that helps, unfortunately. I still like your idea from earlier about thinking where 7, 8, 9s are on the diagonals.
Right, because we now have a few 7, 8, 9s off diagonals.
Yeah, the fact that those 3 are off the diagonals in that box is really interesting.
Like, this digit has to make it onto the negative diagonal somewhere.
Mm-hmm. So if you look at 1 on the negative diagonal, it actually only has 3 places it can possibly go. Row 5, column 5, or it's in box 9. If it's in box 9, then this has to be exactly 2, 3, 4 in exactly that order. And so that would be 2, 3, 4 with a 9 up there. That would have to be an 8 up there in box 3.
Yep, with the 4, 5, 6, 7 Renbon.
Mm-hmm. And the 1. Oh, wait. That would break. Because
Ooh,
where would it put 1 in the column?
3, 4, 4, 5, 6, 7. Nowhere for 1 in the column.
Yep, it would put 1 in the column in box 3, which would then break the arrow that can't be a 9. Because here's the thing, actually, we could have just asked the question this way. Where is the 1 in column 9? And it's not in row 2, column 9 because of the pencil mark. So the 1 in column 9 can only go in box 9.
Right, one of these must be a 1,
Right.
which
And
just
so
places
that
1
does
there.
place the 1. Yep. Because and the reason for that, just to explain it for the video, is because we need a 1 on both diagonals.
So now
And
we
now
need,
that 1 from both diagonals has to be in box 5. And
right, so we need
so
a
I
1 in
can't put
these
2 ones.
cells and we need a 1 in these cells.
And the only way that works is to put it there in the center. So that feels helpful.
Yeah.
It also means my claim that we were going to need to prove that the 9 arrow was 2, 3, 4 failed.
Oops.
Uh, so we can rule 1 out of row 7, column 8 now.
So is the 9 arrow going to need a 6 on it is a question.
I'm going to go with probably. Can we pencil mark based on probably? That is the question.
Which would mean the corresponding Renbon was 2, 3, 4, 5. Oh, I guess unless it was this one. So we have to put a 2 and a 6 in both row 1 and column 9.
Mm-hmm.
But there's like these cells that we don't know much about that provide some wiggle room there that's a little annoying.
Yes, I agree.
Although, if there was, for instance, a 2 here, you certainly couldn't have these being 3, 4, 5, 6. They would have to be 4, 5, 6, 7.
That is a good point.
It's like a 2 and a 3. Oh, but wait.
Oh, I see something.
1 and a 3. What do you see?
Where do the digits on the yellow vertical Renbon go in box 9?
Ah, well, one of them could
One
could
of them could be a 7. If none of them are a 7, and that's just exactly them there in the square. Is that possible? Because it seems like maybe we could disprove that possibility. In that instance, uh, let's see, what would these two? So what would have to be on the Renbon if it's not a 7? Then we could do 2, 3, 4, 5. In which case that would be a 1, 6, and this would be a 2, 3, 4, 5 mess. Uh, and it would place the 2 and the 3, and then the 4 and the 5, uh, but not in a way that looks problematical, unfortunately.
Yeah, I'm not sure.
It looked so promising when I saw
Yeah,
it because the 7, 8, 9 pencil marks down there are suspicious.
they really
Uh,
are.
like it seems like something we should be looking at, but I do not know what it tells us.
Like we have a 2, 3, 4, 5, 6, but these are all from 2, 3, 4, 5, 6.
Yeah, those are all from 2, 3, 4, 5, 6.
So these are like seems very good Liffy to write that down.
I actually kind of want to even write down the other one because I want to think about this diagonal and the fact that we still have to put. Oh, we still have to put one more 7, 8, 9 on this diagonal.
Right, just one.
Yep. And it could go in a few places. I'd love to know any pair of these 7, 8, 9s are the same. Would be super helpful.
I mean, if this cell isn't a 7, then it definitely goes here.
And so then it definitely goes. Oh no, I was going to say that it definitely it's still got 2 places in box 7. Box 7 keeps playing where there's like two places for any particular 7, 8, 9 that we look for.
Yeah.
Uh, but 2 is one too many. So one thing I look at is I look at 1 looking into box 6, and it seems to me like that little length 2 Renbon is there to tell us that the 1 can't go there. I don't see why that can't be a 1-2. Do you see something that breaks if that's exactly 1-2?
I do not.
So we're still in the point of considering uh, the existence of 2s and 7s on these yellow Renbon.
Mm-hmm.
And so just to recall what we've said at most one of them has a 2, and at most one of them has a 7.
Yeah, that's right.
But either of them could have neither and be exactly 3, 4, 5, 6.
So if one of these is a 3, 4, 5, 6, then the arrow it points at is forced to be a 1, 2,
Mm-hmm.
but then that cell still has options.
If row 1, column 9, if that is a 7,
Okay?
that rules 7 off of both of these Renbon. Then both of these Renbon also have a 3.
Yep.
Um, does that do anything?
See, that would be a 4. You would need a 4 in one of these. Let's
Yeah, that would
see.
be a 4 with a
Would be 1,
1-2
2. This would
pair.
have to be exactly 3, 4, 5, 6
Yep.
with an 8, 9 pair over here.
Yep.
And this could still have a 2 on it, I think.
Making that exactly a
1 and
1-6
6.
with a 2 over there.
The 2 and a 9.
Yeah, I guess that doesn't seem to break as best as I can tell.
And then the 2 goes in here, and you have a 2 here, and it all seems to work out.
The fact that 7 has to be exactly 1, 2, 4 is definitely suspicious. Like in terms of maybe we're supposed to be thinking about where the 7 goes or something like that. Uh,
And the 4 would always have to go in the sticky out cell.
so we know one of the sticky out cells. We know one of those is a 4,
One of these
and
is
it
a
goes with a
4.
7.
Because all of these cells have 4s looking at them.
Yeah, that's interesting. Can 2 of those cells be a 4?
Can 2 of these cells be a 4? And that pushes a 4 in here.
Pushes a 4 onto the diagonal somewhere in the middle.
Oh, yeah, I suppose it does.
If it was those two in particular, I was just curious to see because the two ways to make 8 are 1, 2, 5 and 1, 3, 4. If we only were able to put 1, 4, then we'd know that the 8 had to be 1, 2, 5, which would be helpful. Here's a point. We can't use a 2 on every arrow. Because if we use a 2 on every arrow, then we've broken box 5.
Okay.
So that means either the 8 is 1, 3, 4, Or the 9 is 135.
Okay, I agree. So you could have a 135 here,
Mm-hmm.
this being exactly 234. And that seems pretty harmless in terms of the rest of the grid. Otherwise, one of these uh, dominoes has to be a 1-3 domino.
Which would force the yellow one to be exactly 4, 5, 6, 7.
Yes.
Force the 8, 9 to be in the row or the column. Yeah, these dang sevens on the Renbon. I I'd really love to be able to say something that would let us place the like knock out a 7 candidate or something, but just can't quite get there. I'm squinting at box 7, looking at what digits we have to put in it. Uh, Namely, we need to put a 4, 5.
Yeah,
Uh,
we have to put the other 4-5 and the other two 7-8-9s. That's what these three cells are.
the other two 789. So yeah, two of these cells are 789.
So at least one of these is 7-8-9.
Yeah, that's interesting. Could it possibly be both? That would be 789s for the diagonal. So then the rest of the diagonal would have to be from 2, 3, 4, 5. I don't see anything immediately wrong with that.
Yeah, I don't either. So that would put a 4-5 pair in this row, knocking 4 and 5 out of these cells.
So tantalizingly close. Is there something that goes wrong if one of these two sticky outy parts of the yellow run bonds is a 4 or 5?
Oh, these?
If that's a 4 or 5, yeah.
So, like, if this was a 4, this definitely couldn't be a 7. So 4 does a lot of damage. But I don't know that 5 is similarly powerful.
The 789s in box 7 is an interesting little dance. Uh, so let's think about this Renbon in column 3 again. So Renbon in column 3 is maybe a 4 or 5. Uh, Maybe it's a 5, 6. Maybe it's a 6, 7. But I think it's possible if it gets to 7, 8, we might have problems. If it's 7, 8, then we've got our 7, 8, 9 triple in the box. Uh, I don't know. Maybe that's not a problem.
I really don't see the problem with this being 7-8 or 8-9.
Green 4, 5, interestingly, can only go in one of the two places, or in one of two places in box 9.
So one of these is green.
Yeah, one of those is green. Don't know if that is at all potentially interesting. Uh, the 3 in box 1 we know is in one of three places. He said that, but we didn't pencil mark it.
So it's oh, yeah, okay, well, no, that doesn't really tell us much. Because we know there's a 3 in one of these cells.
Mm-hmm.
We got a few digits early and we were so dancy, but I feel like there's like some additional kind of break in that we haven't gotten yet.
Yep, there definitely is.
So 2, 3, 4, 5 forces 1, 6, and a 9. 4, 5, 6, 7 forces 1, 2.
But couldn't it be 1-3?
Oh, or 1, 3.
But always with a 4, right? On the end of the arrow? Oh no, it could be a 4 or a 5.
Yeah. So if this has a 2 on it, this is 9. If this has a 7 on it, this is 8 or 9. So
That's interesting.
the only way this can be 7 is if this is 3, 4, 5, 6.
That's very interesting.
Now what can we do with that?
And the same, presumably, is true of that one as well.
So if this is 2, 3, 4, 5, you get a 1, 6 here and a 9. If this is 4, 5, 6, 7, this is obviously 8 or 9. So if we want this to be 7, this needs to be 3, 4, 5, 6. So one of these being 7 forces a 3, 4, 5, 6 Renbon.
Yep, I agree.
But if this is 7, I mean, if this is 7, it is going to force a 3, 4, 5 Renbon.
What about the Renbon in column 5?
This?
Yeah. Because it's under a lot of pressure from the Renbon above it and the Renbon it's pointing down at. If it wants to be something like, well, it just can't be 4-5.
Sure.
But if it wants to be 3-4, that's going to do a lot of damage. Uh,
You get a 3, 4, 5 triple in the column.
and a 3 in row 1, column 2, I
Mm-hmm.
think. Uh,
Well, what if this
that would be a
was.
4 or 5.
This could be a 3 or a 4, I think.
So maybe that's the question. Where do the digits on this little Renbon go in row 1? And so that's going to depend on whether there's a common digit between this little itty bitty Renbon and the giant length 4 Renbon.
That's true.
And so if there are digits in common, uh, what can those digits be? Well, there can only be one common digit, of course. So the one common digit could be.
Could be 3.
So if this is a 2-3, you're saying then the common digit is 3? Yeah, so let's just write out. What if that is 2-3? What happens?
If this
If this
is.
is 2-3,
Then this Renbon can't have a 2 on it at all.
yep. So it is either 3, 4, 5, 6 or 4, 5, 6, 7.
Oh, well, we can't put a 3 here.
Oh, yeah, we can't put a 3 there. That's right. So yeah, this
If
if
this
this
is
is
a
2
2, 3,
3,
then this has to be 4, 5, 6, 7.
okay, that's interesting. Okay, and so what does that do again? Let's recall if that's 4, 5, 6, 7,
That
that makes
makes.
that an 8-9 pair. Uh, And what does that look like in row one? If those are an 8-9 pair, it means yeah, these three other cells become a 1, 2, 3 triple.
Yes.
But we know one of those two arrows has a 3 on it, but it could easily just be the one over there, so that's not so exciting. Uh, okay, so that seems plausible. If this tries to be 3, 4,
Then this is still 4, 5, 6, 7, I think, with the 4 here.
so that's interesting. And I'm noting as we think about this exact same thing happens in box 6. So uh, we might be trying to figure out that one of these has to be higher because they can't both have a 7 on them. And so we've said if this is 2, 3, it forces there to be a 7. If this is 3, 4, it forces there to be a 7. Uh, if this is 4, 5, it just outright breaks.
Right? Can't be 4,
Uh,
5.
uh, is it true if the other one, by the way, is 2, 3 that it forces the thing we said? Does that force it to be? Uh,
Mm, well, the
because
problem is this can be 3, as far as we know.
yeah, that was what I was slightly concerned about.
So
But
I don't think it does the same thing.
so if it's 5, 6, and it forces the 5 to go up there, and it forces this thing not to have a 6 on it. So if either of these length 2 Renbons is 5, 6, and it forces the Renbon to be exactly 2, 3, 4, 5, which again forces one of these to be a 9. One of the arrow circles to be a 9.
Right.
With a 1, 6. And then an 7, 8, 9 there. So maybe what are the actual candidates for row 1, column 2? Maybe that's a smart question to ask because it can't be that many things, right?
Can't be 1. Don't see it why it couldn't be 2.
Let's see. If it is 2, then that makes this a 1, 5, 3 with a 9 in the circle. Uh, and so that makes this Renbon line have to be exactly 3, 4, 5, 6, which it can't be.
Wait, what?
Is that yeah, it can't be a 2.
Okay, so if this is 2, we get 1, 5 with 3, and a 9.
That's a 9. hmm Now this Renbon can't have a 7 on it.
Because we have a 9 here, and we said if there's a 7 on this Renbon, it forces a 9 here. So it is 3, 4, 5, 6. And we're broke.
Wait, did it force a 9 there, or did it just force a 9 at one of the ends? Maybe it just forced a 9 at one of the ends. Maybe we
No,
misremember that. So
no, if
let's just write it up.
no,
So if that's
if this is 4, 5, 6, 7, you must put 1, 6 here. Wait,
no, unfortunately that's
sorry.
if it's 2, 3, 4, 5.
Yes, I was thinking it was 2, 3, 4, 5.
Yeah,
I get it.
I went down the same path. But yeah, so in fact if there's a 2 there, it has to be 4, 5, 6, 7. That has to be an 8. Uh
With 1, 3, 4.
yeah, so okay. So I think the upshot is I think it can be a 2.
Yeah.
Uh if it's a 3, what does it do to the Renbon? If it's a 3, it makes the Renbon a 4, 5, 6, 7 automatically.
Yep.
Uh, so now
So now this is a
this is
9.
a
Wait, I did it again. Oh,
so that being a 4, 5, 6, 7 means that this is an 8, 9 pair in the arrows. But that is now a 1, 2 pair over there in the row.
so, yeah.
And so that is
Five,
5 or
5 or
6.
6.
And then this over here is
We have no 3
also,
available.
we have no 3 available. So this will be 1, 2.
With 5 or 6 again.
No, that can't be 1, 2. That will have to be 1, 5 because remember we need a 2 in we need one arrow to not use a 2. And we forced the arrow in row 1 to use a 2 if that's a 3. So this would have to be 1, 5 and then 2 or 3 there. So we'd have a 2, 3 pair.
Well, we've
Uh,
used 3. This is all predicated
oh,
on
sorry.
this
Yes.
being a 3.
Yes, that being 3. So this would have to be 1, 5 and 2 to make 8. And that over there would then have to be 1, 2, and 6 to make 9.
Wait, well, that breaks. We've just used 2 in both our 8 and our 9.
Oh, that's right, because we have to not use 2 at all on one of these.
In one of these, we have to not use
Well,
2.
I think that cell can't be 3. Let's go through that again real carefully just to make sure. But I think that cell absolutely can't be 3.
Okay,
So if that's a 3, this has to be 4, 5, 6.
4, 5, 6, 7.
Yeah. Yeah, 4,
So
5, 6,
then
7.
this becomes an 8, 9 pair,
Mm-hmm. And that's a 1, 2 in the row because they're the only digits left.
right?
And so that arrow uses a 2. The other arrow is a 7, so it uses a 2, the one in box 9 that we're not even talking about. So this arrow absolutely cannot use a 2. So that's a 1, 5. And then what do we add to it? Well, we can't add 3 and we can't add 2, so we broke.
Wow.
Okay, that sounds tall catty to me. So that can't be a 3. So we can remove a 3 from the center and remove a 3 from the corner mark. It's definitely not 4 or 5.
Yep.
Okay, so can it be 6?
So 6 forces 2, 3, 4, 5. I don't think that works because then how do you fill these?
Yep, so it can't be 6.
But it could possibly be any of 7, 8, and 9.
Well, let's look at 7 real quick. What if it's 7? It's 7. This is now an 8, 9 pair. We now have to use a 3.
Yeah, so what's this going to be? It's
Going to be either 3, 4, 5, 6. In which case, that's going to be a 1, 2 pair over there.
so then we couldn't use a 2 over here.
Right. So we'd have to be 1, 5, and 3.
Okay.
So 1, 5, and 3 is 9. So over here we have to make 8.
With 1,
And s-
2, and 5. I think that works.
yeah, that all seems fine to me.
So yeah, I think this can be 7, 8, or 9.
So if it is an 8, this is a 7, 9 pair. So one of these is 1, 2, 4 exactly.
Yes.
Uh, But I don't know that that does us a whole heap of good. But that cell was very restricted. Uh, I really want to know if it's possible we're supposed to be showing that that thing can't be 2, because that would sure be helpful if it could not be 2. Uh, so our Renbon always contains a 2 or a 6.
Sure. That's trivially true.
I was just hoping that it was going to turn out that actually it was obvious for some reason we could not make 1, 3, 4 as the 8 on any of the arrows. Uh, so we definitely can't make 1, 3, 4 in box 1. Can we make 1, 3, 4 over here? So that's 1, 3, 4. The 4 has to be at the bottom, of course. That's 1, 3 up there. And that's the case where we get a 2 over there. And then that arrow becomes a 9.
This one?
Yep, with a 1, 5, 3. And then we're obligated to make row 7, column 7 a 3, because we need to preserve the flexibility of our ability to put a 3 on the positive diagonal in box 5. So in fact, we'd even know the exact order of this 1, 3, 4 arrow.
Yep.
Yeah, this would be 1, 5, 3. Yeah, and then we'd have to put a 3 somewhere in row 2 and box 2, and that all seems perfectly fine. Okay, so that's not the secret. So what about if I try and put 1, 3, 4 on the arrow in box 9? Does that work?
Like that?
Is that the exact way it has to go?
I believe it is.
Yeah, because I can't put a 4 anywhere else, and then I can't put a 3 there. So yeah, it would have to go 1, 3, 4 like that. Now the vertical Renbon is forced to be 4, 5, 6, 7. Oh, which interestingly puts a 2 there. Uh,
So
so now this is 1, 3, 5. And that breaks, I think. Yep, that breaks.
okay.
Because where does 2 go in row 1 now?
It goes here.
And now we can't make a 7.
Oh, because this should be 4, 5,
But
6, 7.
by putting a 1, 3 pair, so yeah, this is okay. I think this is actually the point. By making a 1, 3 pair, looking at the Renbon, we actually force there to be a 2 in the column, because 2 can't go on the Renbon anymore. But now we've forced another 1, 3 because of the fact that a 1, 3 pair needs to go with a 4 or 5. And now we force 2 off of that. And so we have this chain of 1, 3s breaking where the 2 goes. So I think the point is we can't make this a 1, 3 pair. I don't think, for this reason. I think as soon as we make this a 3, as soon as we make row 7, column 9, as soon as that's a 3, I think we have doomed ourselves, because we have forced 2,
So then that would have to be a 1.
right, because of the 1 in the column, and now we forced 2 into row 2, column 9. which then has forced this to be a 1, 3, which has then forced 2 into row 1, column 2, and then the world is broken.
And now you can't put 7 in any of these, is the
Right.
point?
I think that is the point. So yeah, so that cell can't be a 3.
Okay. But we don't run into similar problems if this is a 1-3 pair?
So if that's a 1, 3 pair, we do force the 2 over there. And so we do force 7 down in box 9. So we get that arrangement. So this is an 8, 9 pair.
So this is 4 or 5?
Mm-hmm. And we have to have a 1, 5 pair in box 1 now. And so that's a 3 to go with it.
So
That's
that's
a
a 9.
9. 8, that's a 4. Uh,
Wait, what is this? Oh, it's 4, 5, 6, 7.
but now the question is, where are we putting the 2? And so the 2 in box, the 2 here has to go on the diagonal, because that was the whole point. We needed some place where we could put the 2 on the diagonal. It's not just we need a, yeah. Uh, so I think this is okay. So maybe that's the question, is not just to ask, where are we not using a 2, but where are we putting a 2 on the diagonal? And so in that box, it's okay to put a 2 on the diagonal. In box 3, what happens if we try and put a 2 on the diagonal in box 9? Then we get a 1, 6. Yeah, wait. Do we really, is that really 1, 2, 6 down there? Or did our pencil marks get screwed up?
I think it's 1, 2, 6.
Us knocking a 3 out of that actually did an enormous amount of work, because now we can't put 2 on the diagonal in this box.
Oh, yeah. That's a good point.
So I
So
think
there's
maybe we're
always a 2 on this arrow now.
yes. I think we might accidentally have stumbled upon the correct solve path of this now.
So there's no 2 in these cells.
Right,
So
there's no
now,
2 on those.
well, the could we still put a 2 up here though?
So if we put a 2 up there, then this has to be 1, 5, 3 exactly. And so that is a 2, 3, 4 reading down the green, with a 4 down there and a 2, 3 pair there. I don't immediately see why this doesn't work. But I do think row 7, column 8, I think is now quite a bit more restricted. Because this is either a 1, 2, in which case, oh no, are we doing this again? Maybe we're doing this again. If that's a 1, 2, this is a 4, 5, or 6.
Great.
If this is a 1, 6, uh,
It's a 2.
then
So I
it's,
guess this isn't a 3, is it?
let's
Do we
see,
get a
is it not a
3?
3?
If
The
this is
1,
3,
2,
what are we doing with these?
yeah, it can't be 1, 2, and it can't be 1, 6. Okay, yeah, so that's not a 3.
So this is a 3.
Yep, and that places the 3 in box 1.
Okay. Progress. So
And so now
now,
that tells us that can't be a 1, 2 anymore.
so this is 1, 5.
Yep. which is going to determine the column and determine the sum of this arrow.
So that's a 4. This is a 2, 3.
Mm-hmm.
This
And so that's
now
a
is a 9.
9.
And it doesn't use a 2, so we have satisfied our something must not use a 2.
Well, we haven't put a 2 on a diagonal yet, keep in mind.
That's true.
We still have to put a 2 on a diagonal somewhere.
Twice.
But let's do a little bit of Sudoku with 4. So the 4 in row 7 actually tells us that's not the 7 arrow in box 9. So
Yes.
the 7 arrow is actually in box 3.
So this must be an 8
Yes, so that must be an 8.
with 1, 2, and 5.
Yep, that's the only way that's going to work.
So this is a 7 with 1, 1, 2, and 4.
4. And now 8 in row 1 is certainly placed.
8 has to go here.
Yes. Okay, so now we have lots of Sudoku cleanup duty to do.
And these are 3, 4, 5, and 6.
Yep. And
This
likewise, the
one is
9
not
in
3.
column 9 is placed. Yep.
That's not a 9. You're saying 9 is here, which seems right.
Yep. And these are a 3, 4, 5, 6. So the answer was they were both 3, 4, 5, 6 after all the time we spent analyzing whether how many of them could be 2, 3, 4, 5, and how many of them could be 4, 5, 6, 7, and what combinations they could be in. They were all 3, 4, 5, 6 the whole time.
Yep.
So 5 in box 9 has given you a 6 as well, and a 4. Those aren't 8, of course. We can remove a 4 as a candidate from a cell and a 5 in box 7. In fact, all of box 7 can't be 4, but some of it's looking at a 5 now. In fact, so now those are 7, 8, 9. So that is the 5. So the 5 is in one of 3 cells in box 4.
So that's not a 5.
Yep.
Which I guess also.
Yep.
So let's see. 3 is on this diagonal.
So 2 has to go on the diagonal in box 1. And 2 has to go on the positive diagonal in box 5.
Right. 2 is in one of these, so 2 is in one of these.
Yep. And now row 2, column 3, what can it be? It can't be 1, 2, 3, 4. It can't be 5. It could be 6, 7.
And that's
Can't
it.
be 8 or 9. So, yep. Okay, so what digits are left in box 3?
Let's see. 5,
5, 6, 8. And the 5 is definitely in row 3, so that's going to fix our 1 and 5 over in box 1.
This sees a 5 and a 6 by diagonal. That sees a 6.
So the 5 is placed now, and the 6.
5, 6.
Yep. And so now the diagonal has a 3, 8 pair, so that down there is not an 8 or a 7, because it sees a 7 too, so it's a 9. So what's left on the diagonal? 2 and what? 2 and no, not 8. 2 and 4.
We're
Got there
blind.
eventually. The 8 in column 2 looks down at the 7, 8 and fixes those. So the Renbon in column 3, I know I've had a lot of false alarms on this, but I think we might finally be able to nail it down. It's not 1, 2. It doesn't involve a 3. Uh, it could be 4, 5, 6. Can't be 6, 7. Uh,
Could
oh, I
it be
guess I
7,
don't.
8?
Yeah, I guess I don't know that it can't be 7, 8. It could be 8, 9. I can say that. Uh,
I don't know. Maybe that's not quite up to pencil marking.
yeah, maybe we're not quite there yet. Now, the one that's in it can't be 7, 8 because if you clean up column 1's pencil marks, it will tell you that that's a 7.
Oh, how about that?
So
Okay,
I think it does have to be 4, 5, 6.
so now the 5 isn't there.
Yep, I believe that that is true.
And we have a 4, 5, 6 triple, so that gives us a 7.
Mm-hmm. But now 7 has to go on the diagonal. It can only go one place.
Here.
Now 7's in one of two places in box 2. Sudoku in row 3 gives us the 3, 8. There's a 3 in the row.
See, if this is 7, this could still be 6 or 8.
What's left on the negative diagonal? We only have 3 things. There are a 2, a 5, and a 6, I think.
Oh, well, that's also not 5.
Yep, so that's a 2, that's a 6, that's a 5.
So,
What is
so that places
oh,
5 here.
there's a 2 looking down in column 3.
And this is
And
an
what's left in this column, yeah, this is a write-in, is
4? No, 8?
8. Could be an 8. 8 sounds good. Oh, and where does 6 go in box 4?
6 in box 4.
Also known as look at box 1.
So that's a 6, that's a 4. These are exactly 3, 5, and 6. That one's not
Mm-hmm.
5. It's left in this column, by the way.
Yep, a 1, 4, and a 9, I believe.
It's not 1.
We have a 6 in row 4. We probably should strip off that pencil mark.
All right, now can we say anything about this?
Annoyingly, I think it could still be 8, 9,
Yeah,
which is the thing we don't want it to be, but it could still be, I think. Let's see. What about row 2? What's left in row 2? That should be helpful. 1, 2, 3. Not 3, sorry. 8. 1, 2, 8. Middle one's not a 1.
if
So
this
that
is a
can't be a
2,
2.
this
Can't be
is
a 2.
just an 8.
Yep.
So this is a
So
7
8
or a
could go with
9.
7s or 9s. Yep. And so the 2, that's an X-wing on 2s between box 2 and 5, which doesn't actually place the 2 in box 7, or sorry, box 8, but at least gives us a 2 pencil mark. Is something. Let's pencil mark box 5, by the way, while we're at it. Box 5 is missing a 3, 6, 8, and 9. Which we may know disappointingly little about, but
Oh,
hopefully
this one's
someday we
only
will
a
know
3 or a
something.
9.
Let's see. Where does 5 go in column 5? I think it can only go at the top.
And it can't go here because.
Oh, dagnammit. I retract. But the other cell's not a 5. The one to the left of that one. 5 in box 6 really is placed by Sudoku, I think.
Oh, yeah, we've got 4 5s looking into it.
So what's left in this column? 1, 2, 7, 9. That's not a 7 at the top.
See, I think this only can't be a 1 2 pair by uniqueness.
I think if you ask where 8 goes in the row, I think it has to have an 8 on it.
Oh,
Yeah, because we forced 8 into row 5 in box 5, which I noticed and then immediately forgot.
so this is just an 8 because there's nowhere else
Mhm.
for 8.
Yep, and
So
then that's a
that's a
7 or a
9.
9.
So that's a 3.
Why wasn't that cell a 7 again?
Why wasn't that? Oh, but there's a 7 in the row.
Oh, there's a 7 in the row. That is a very good reason. That's a 3. So that gives us the 4 in the row. Gives us the
Ah,
2. Oh,
the
let's
2.
see. It can finish row 4. That's a
Uh,
2, and that's a 1. The 9 gives us the 7, 9 in box 9. So what's left in this column? Still need a 1, a 2, a 7, you believe? The bottom one's not 7. The top ones aren't 1. So 1's actually placed in this box.
so 7. And 1 you said was here.
Yep. And that gives us the 2, 3 over in box 4. None of those are 3. So the
Uh oh,
9 in that
I
box.
messed up.
Yeah, you did something with green over there. Go back to where you put in green because I got lost by what you were doing.
Okay, I think I was fine up until here, but
Okay, if you're sure, uh,
I'm pretty sure.
okay,
I think I took a 9 out of these pencil marks when I
yeah.
wasn't
So
supposed to.
green 3 gives you a yellow 6.
Now this one is just a 6, I think. And these are not 3 and not 6. They are 8 and 9. And I think we're correct here.
Okay, the 4 in column 4 looks down at the 3 4. That 3 looks up at the 3 6. That 3 in column 5 fixes that, which then fixes row 9. We can fill out box 2. Box 2 still needs 4, 7, and a 9. We know where the 4 goes. Let's see. Yeah, let's just fill in this box. Uh, Not 8 or 6 in this row. And then not 7 or 9 in the row above it. And now not 6 or 8 in column 5 or 1. So in column 5, we just get a 2 there. And that's not a 1 either.
7 or a 9.
You can pull 2 out of all the rest of the box. 7, we already have 1 in in column 6. But we already have a 1 in column 6 as well, which fixes our 1 2. Sorry, we already have a 2, which
Uh,
fixes our 1 2.
uh,
And that one is useful because it's going to fill out the rest of this box. So that 9 looks
That's
up.
6,
Yep.
and that 8,
Hmm.
9, 8, and 7, and 9. We have a 2 here, giving us 1 and the 2, and this 2 gives us 1 and 2.
Nicely done.
Wow.
Woohoo!
Well,
Nice puzzle, tallcat.
yes, very nice puzzle, Tallcat. Um, I will. This is our first attempt at recording like this. I don't know how the video has come out. I don't know how the audio has come out. This is a new adventure, so we will see what this looks like. We will get this up on the channel, and we will see about recording other puzzles in the future together. Zetamath streams every Saturday, and possibly
And
more.
Wednesday.
It's official. We're doing every Wednesday and Saturday.
We are officially doing every Wednesday and Saturday for the immediate future. Of course, I reserve the right to change plans at any moment.
If you would like to support our content, we have a Patreon. There is a link in the description,
Why
and
don't
we'll
we
see
wrap
you.
up and have dinner?
Yes, and we'll see you next time.